Hello and welcome. Today we're diving into the fascinating world of cognitive load theory. Whether you're an educator, a student, or just curious about how we learn, this video is for you. Let's start with the basics, our memory. When it comes to learning and our cognition, we have our working memory and our long-term memory. We have lots of storage for long-term memory. This is where we store information we've learned or those evolutionary skills we just seem to know how to do. Our working memory does not have as much space, as it's intended to hold and manipulate information over shorter periods of time. When we encounter something new, it goes into our working memory, while we process the new information into our long-term memory. What ends up in that long-term memory is what we have learned. Because we do not have as much space in our working memory, we must be intentional with how we use it. Cognitive load refers to the amount of mental effort being used in the working memory. It's a crucial concept in understanding how we process information and learn new things. There are three types of cognitive load: intrinsic, extraneous, and germane. Intrinsic load is the difficulty of the material itself. For example, learning a new language has a high intrinsic load because it's hard to learn a new language. Extraneous load, on the other hand, is all about how the information is presented. Poorly designed instructional materials can increase this load, making it harder for learners to understand the content. Have you ever taken an online class where you could not locate the materials, were confused about instructions, or did not understand what was expected of you? Chances are you faced a high extraneous cognitive load. Finally, we have germane load, which is the mental effort we put into creating and organizing our mental structures, our schemas, that help us understand and remember information. Now, why is this important? Well, understanding these types of cognitive load can help us design better educational materials and improve learning outcomes. For instance, by reducing extraneous load, we can free up more cognitive resources for intrinsic and germane load, leading to more effective learning. Let's take a closer look at some practical applications. Imagine you're watching a video with subtitles. Studies have shown that watching videos without sound increases cognitive load, because all of that processing must be done visually. Instead of splitting the processing duties between the sounds, tone of voice of the actors, environmental noise, imagery, and captions, all we have is silent imagery and captions. This can make comprehension and recall more challenging, as more input is being funneled through the same singular visual channel. So, what can we do? By ensuring that instructional materials are well designed and presented in a way that minimizes extraneous load, we can make learning more efficient and enjoyable for everyone. Thanks for joining us today. Hope you found this introduction to cognitive load theory helpful. Remember, understanding how we learn is the first step to becoming better learners and educators. See you next time.